Okay, we're going to work 5.1 here. In 5.1, we're given a picture. Okay, so the problem is kind of graphical in nature. And what it is there's a flask that's basically sealed off from the atmosphere. And inside this glass flask, we've got a sample of some gas. We don't really know what it is. We don't really care all that much. But we know that that gas will exert a pressure. And we want to know what the pressure of that gas is. And the clues or the cues that we're given here is that gas sample is basically plumbed into a U-tube manometer here, okay? And there's two fluid levels. One level is here on the left, and on the right, the fluid level is down here. And basically this whole tube then is filled in with a fluid, and that fluid's mercury. I don't think it explicitly says that in the problem, so I guess that may be a little bit confusing, but it's meant to be mercury. Okay? And notice that the two fluid levels are not the same. There's a difference, or a delta H, a difference in height. Whenever you see this triangle, we read that delta, and it means there's a difference in something. Okay? Here's a difference in height between the columns. And the magnitude of that delta H, if I was to actually measure it with a ruler, is 2.35 centimeters. So this fluid level is 2.35 centimeters higher than that one. We're given the atmospheric pressure. We're told that it's 738.5 torr. And we want to know, based on all this information, what is the pressure of this gas sample? What should I report that as, okay? Turns out maybe this problem's a little bit confusing, but it's actually pretty simple, okay? Because what we're actually doing with this device and these fluid levels is we're comparing the pressure inside this chamber compared to the atmospheric pressure. So which fluid level is higher tells us which pressure is winning or which pressure is higher. Now it looks like to me that in this tug of war, the atmospheric pressure, this end of the tube is open to the atmosphere, okay? So the atmospheric pressure is pushing down on this. It seems like that's winning. Okay, this tug of war, this balance, because the fluid level here is lower than the fluid level is here. So the atmospheric pressure must be higher than the pressure of the gas inside this chamber, okay? Because it's pushing harder, if you will, than this gas sample. So we know the gas sample is less than atmospheric pressure, less than 738.5 torr. But the question is well, what exactly is the gas pressure? We know it's less than the 738.5, but can we actually measure it? And the answer, of course, is yes. Now, remember that 1 torr is physically equivalent to 1 millimeter of mercury. And that's kind of important for this problem, okay? Because I know that 738.5 torr is then equal to 738.5 millimeters of mercury. The two are indistinguishable, okay? Now I did this quick unit conversion, and that's crucial, okay? Because note that this fluid level difference is a distance. I can convert this to millimeters, and if I did so, it would be, what, 23.5 millimeters. And it's not millimeters of anything. Remember I said I filled this up with mercury? So the fluid level difference is 23.5 millimeters of mercury, in fact, okay? So hopefully you can kind of see where I'm going with this. But the pressure of the gas inside this chamber is the atmospheric pressure minus the difference in fluid level. They both have the same units. So we're allowed to do this. And if you do the subtraction, you get 715 millimeters of mercury for the pressure of the gas inside that chamber. Okay? Now, does this all make sense? Well, the atmospheric pressure is stronger. It's a higher pressure. It's winning this tug of war. By how much? Well, 23.5 millimeters. Right? We're given that in this figure. Okay? Now, one more thing. This problem, and I didn't explicitly say it, okay? But the problem in the book asks for your answer in atmospheres, not in millimeters of mercury. If it asked in millimeters of mercury or didn't specify, this would be an acceptable answer. But it did ask for us to convert to atmospheres. So let's do that real fast. It's pretty easy. Because we know that 1 atmosphere of pressure corresponds to 760 millimeters of mercury. So the millimeters of mercury units cancel. I take this, divide it by 760. And when I do that, I get 0.941 atmospheres with 30 sig figs. And I have 3 sig figs here, 2 decimal places. This one's only got, where do we start? Okay, this one's got 1 decimal place. So I did the subtraction first, right? So the answer there really should have 1 decimal place as well, which means I should have 0 here. But nonetheless, this 0.941 is our pressure in atmospheres.